Since I was too lazy to submit a proper talk this Lambda Days, I apologize for that. I'll give you a short lightning talk about what we are up to in the GRiSP ecosystem. Short reminder what GRiSP is about. GRiSP is a software stack where we run the Erlang VM directly on hardware. So we basically bake it together with some unikernel, what we would call it today, and then boot the whole thing on the hardware. So we basically have direct access to the hardware, and we have a hard real-time substrate that we are running on. So Erlang soft real-time is getting much harder. It's actually amazingly hard real-time already. And to actually make a nice user experience for that, we decided to build an evaluation board for that, and this is the second version, the GRISP 2 board that exists for a while. We ran a Kickstarter for that, which took forever, by the way. I apologize for that. And so this is out already. So now we do new hardware because we can't kind of like refuse to do hardware. So this is PMODs, or maybe look at the black connectors on the top, like the 5 connectors. That's where you can plug PMODs in, which is little modules, which are basically an industry standard made by Digiland. You can get a bunch of hundreds of PMODs, but, well, there's always not the PMODs that we want, so we made 3 more PMODs for now. The little one in the middle is a digital I/O with 24 volts, basically compatible with industrial control systems. The one around with the wire is an RFID antenna with 13 megahertz, which also supports NFC, so you can read all the usual smart cards and tags. And the big one is an ultra-wideband transceiver. Ultra-wideband is very interesting for indoor location and personal area network. That's the new standard. Gives you 7 megabits, very low battery use, and 7 megabits of bandwidth with very low battery use and indoor location, so you can actually measure time of flight with it. So that's 3 PMODs that are out. A Kickstarter is coming soon. These will not take us long because we already have the hardware and we only do production. So this will be a quick Kickstarter, no long wait. So for these hardwares, we use these PMODs for our own projects. So we actually use the GRISP 2 board and the PMODs to prototype the device that you see below, which is industrial GRISP. So this is a real product for being used in industrial manufacturing, but this is a prototype still, which is supposed to be waterproof and has 24 volt IOs and an RFID antenna, which you see on the side. And actually, it kind of like showed that our approach to kind of like use PMODs, which are not very expensive to develop, to prototype things, and then we actually build the actual hardware, the final product. We already have the software running and know everything is validated. One other thing that we have in the pipeline, which, well, I didn't get my hands on it, but these are the first pictures of the hardware devs. That's the GRISP Charger. That's an extension board that goes on top of the GRISP 2 board, which takes a lithium-ion battery, like an 18650, like the standard cell, which kind of like basically gives you battery power for the GRISP, but also lets you control the battery charge. So there's charging chips there and charging management chips, and we provide libraries so you can actually do battery-aware computing. So you can ask your battery, how much do you have, and you can go into special power save modes and use less power when the battery gets empty and whatever. So that's kind of like the thing that we already have concretely in the pipeline with touchable hardware. Next thing is GRISP Zero, kind of like stole the name from Raspberry Pi Zero. So the GRISP 2 board is actually pretty powerful because we also wanted to support nerves, which is another embedded way of running the Erlang VM on hardware. But this uses a Linux kernel, so we actually needed to have a hardware large enough to run a Linux kernel. So GRISP 2 is basically in the three-dimensional space of like power, speed, size, and cost is pretty far out. It's kind of like in the middle to the right. And what we now want to explore is basically how far can we get to the origin of this space, basically this little red triangle that you see. And this will be a lower power CPU, much lower power, so we actually are aiming for energy harvesting applications, running the full Erlang VM, so we want to find the smallest hardware that can run the full Erlang VM. the most power-conserving one. There will be only one communication thing. So GRISP 2 has multiple ways of communicating. There will be only one communication kind of like thing on the module, or maybe on a plug-on module. And there will probably be only 2 PMOD connectors, but configurable, so you can run all the PMODs, but only 2 at the same time. And the communication, the thing what we planned is basically USB on the go. So basically you plug it into your laptop and it kind of like shows up as a network card. That's very convenient for especially developing, because then immediately you can run Erlang distribution over this network. Then also normal Ethernet probably with power over Ethernet. That's one thing that we're considering. And also again, ultra-wideband, remember the PMOD? So now we put ultra-wideband on there because now we have a driver. Ultra-wideband, very low power, so you can have kind of like GRISP nodes, like Erlang nodes, that know where they are in space because they can measure the distance, and that they have very low power communication. And that would be then the thing that would actually work with energy harvesting. We're also building an IoT platform. I can't read all of that because there's not enough time. It will be very cool. It will be a completely new way to do distributed computing. If you want to know more about that, talk to me afterwards. There will be also advantages for GRISP 2 board owners, so they get something for free, because there's a secure element on the GRISP 2 which actually allows it to connect securely to this platform already, and you can do device management and all kinds of things when this will be opening the doors soon. So, end of talk. Oops, I actually didn't want to click on the link, I'm sorry. So for updates, basically there's a mailing list, which was very quiet in the last years. It will stay quiet, so we won't spam you. But if you want updates about the platform or new hardware or whatever, I promise to actually send something in the future. Thank you.
Okay.